Hello everyone. Let us start with a new experiment, that is the soil moisture measurement. In this experiment, the components needed are, that is the soil moisture measuring sensor here and the node MCU. If you observe the pin diagrams here for the sensor, VCC and the ground pin here, and here it is the analog output and the digital output, that is A0 and the D0 here. These are the 4 pins we'll be having, and these are the probes here where we have to insert on the in the soil here. Now this is the power connection from this probe towards this sensor board here. Now the circuit diagram here. This is the probe which is connected to the sensor here, measuring sensor, soil measurement, moisture measurement sensor. Positive is given to positive, negative, that is the power supply connection. And in this here, we are taking the analog output A0. This A0 is connected to the A0 here, and the power supply ground and the VCC here. This is the connection, and the output pin we are taking as the D0 here. Here the D0 we have to connect the either motor or the, to indicate the motor is running. Here in this experiment we are using the LED here. Connect the LED to the D0 pin here, that is the positive of the LED to the D0, and negative should be grounded here, such that indicates the on and off status of the motor here, that particular LED. This is the required circuit here. Next, let us start with the program here. This is the new program. Okay, now the program is entered here. Now we'll create the macros for this particular program here. Search for the Blynk here. Click on the Blynk IoT. Okay, now in the Blynk Cloud app here, enter on the developer zone, new template, give the name of the template here. I'll give as a soil moisture. Now select the hardware, ESP8266, and the description here. Press on the done. Now save it. Now click on the data stream. Enter into edit mode. New data stream. Select the virtual pin. Give the name of the pin here. Moisture. And pin is V0. And this moisture is of the type double. And here maximum value 0 to 100. Create. The moisture, this is created here, data stream. Now create one more data stream for the motor status here. New data stream again. Virtual pin. Here it is the motor. Name is motor. And the virtual pin number is V1 because V0 already selected now. And the data type here is, it is indicating the motor status, whether the motor is on or off. Therefore, it is the string type here. Create it. Now both the data streams are created here. Save it. Okay, now click on the web dashboard here. Enter into edit mode. Select the display for the moisture status as well as the motor status here. First one, this is for the moisture status, and one more is for the motor status here. Okay, now click on the settings. Here it is the for the moisture here. And choose the data stream here. It is the V0 here. Here you can see actually the moisture that status where it should display at the edge or the center or the at the right side here. I'll select the center here. And also you can select the color also here. Okay, now save it. Now for the motor status here, again click on the settings. Data stream here. Here you can write it as a motor. Data stream is V1. Again select the center here, position, and save it. Now both are created here. And save here. Now these are created. Now click on the devices. New device. From the template, choose the template here. That is the soil moisture. Create. Now the macro codes are generated for this particular application here or the project. Now click here to copy the code. The code is copied. Now paste in the program here. Now the program is completed here. Now give the correct Wi-Fi network's name and the password here. Save it. Select the location here. Save it. After this, compile the program. Okay, now the program is compiled here. Now do the connections according to this circuit here. After doing the connection, connect one LED to the pin number D0 here. Now we have to upload the program. Now uploading is completed. Now let us go for the mobile settings here in the mobile app. Open the Blynk app there. Click on the soil moisture. Now click on the settings. Go for the new this one device or the widget. Select the display. Click on the widget and select the which data you need. Next, second one, that is one for moisture and other for the motor we need. Same procedure again. Select the value display. Click on it. Choose the data stream. That is second, it is the motor here. V0 is for the moisture and V1 is for the motor here. Status of the motor, it will shows there. This is the setting in the mobile. Now let us analyze the program here. Now these are the macro codes which are generated in the Blynk app here or the Blynk cloud platform. And these are the unique codes for the each project here. Now this will defines the template ID here. And this is the name of the template. And this is the authentication token here. And this includes the, that is ESP8266. This is connected to the Wi-Fi by including this library here. And this library make sure that it will connect to the Blynk cloud here. Next, we'll be having the Wi-Fi and the Blynk variables here. That is the character AUTS. This is the array here. It will holds the Blynk authentication token here. And the SSID, it will hold, this array will holds the Wi-Fi name here. And the PASS, this array will holds the, all are the character types here. That is the Wi-Fi's password here. And it is the Blynk timer. It will takes care that the all the timed events are carried out here, like the reading sensor data periodically here. Periodically all the events are carried out. And the variable float, it will holds the value of the moisture here. What is the moisture level here? Next, setup function here. That is serial begin 9600. This is for the serial monitor speed here. And we are setting the A0 as the input here because whatever the moisture level is measured, that is given to the A0 pin here. Therefore, A0 pin will be acting as the input here and D0 is the output pin because after measuring the moisture level here, we are sending the output at the D0 pin to turn on the motor here. Or in this case, we are turning on the LED here. Therefore, we are sending the output in the D0 pin. Therefore, the D0 is the output here. Again, the delay, the 100 millisecond or 1 second here. This delay is given such that it will make the system stable before proceeding to the next reading here. Therefore, instead of taking the continuous reading, 1 second delay is given here. Next, we'll be having the Blynk begin here. That is, it will connect the board ESP8266 to the Blynk cloud here. That is using the authentication code and the Wi-Fi name and the password here. Using all these three parameters, it will connect our board to the Blynk platform here. And the timer here, this particular timer, that is the 500 millisecond delay is given. This will set up the timer and calls the my timer function for every 500 milliseconds or 0.5 seconds here. Now the loop function here, that is the Blynk run and the timer run. These two functions will make such that keep the connection to the Blynk cloud continuously here. And also the timer dot run. This will makes the periodically execution of the timer function here. And next is the actual program here, that is the timer function, my timer here. Here in this, the moisture is calculated using the formula moisture is equal to 100 minus, that is unlog read A0, whatever the value we are receiving at the A0, that divided by 1023 into percentage, that is 100. In the form of percentage we are measuring here. The reason for this 1023 is that it is the maximum value of the analog value here, that is in the ADC 1024 or the 1023, the maximum value of the analog. Therefore, by using this, we will get the actual moisture level here. And the particular Blynk virtual write, we are writing whatever this value in the virtual pin V0 here, in the data stream V0. And also we can print on the serial monitor here, that is the soil moisture in the percentage. That is the moisture here. Next, after the again delay here, we are checking whether the moisture level is less or more here. That is, if the moisture level is less than 20. For example, if the soil is dry, if the moisture level is less than 20, then we should on the motor here such that the watering should be done. For that, distal rate denote to the high, means at the output pin we are sending the high signal such that it will turns on the motor, or in this case it is LEDs on here if the moisture level is less than 20. And the status here is the motor is on. Now the motor on, that is this status is we are sending to the in the Blynk cloud, that is the virtual pin V1 here, in the virtual pin V1 data stream. Else, if this is not less than 20, then the moisture level is, it is more only. We have to consider it as the moisture level is more. Therefore, no need to turn on the motor. Therefore, the distal rate denote we are sending the low signal such that the motor is in the off condition only. And we are printing that particular message motor is off on the serial monitor. And that particular message is we are sending to the Blynk platform in the virtual pin V1 here. This is the actual working of the program here. Now let us observe the output here. Now let us observe the output here. Here the moisture level is 0 and the LED is on here. Therefore, the motor is in the on condition here, because the sensors here, the probes we have placed outside here, in the dry condition, these two probes are here. Therefore, the motor is on here. Now, since the soil is also dry condition here, therefore it is showing the readings almost 0 only. Dry soil is there. Some moisture is there, means it is showing some value here. Now the motor is on because LED is on. Now we'll put some water in the soil here. Now as you can see, we have put some water in the soil here. Now as we are touching the probe in the soil, it will senses that, and the moisture level has increased to 53 or 55 here. 58, and also motor is in the off condition. In the mobile also we can observe these things. Motor is off because LED is off. This is the moisture level here. Now if you remove once again the probe from the water, again the motor has turned on here and the moisture level is 0. LED is on, therefore the moisture level is 0. You can see here. Now this is the experiment for the soil moisture measurement using the Blynk cloud app here. Thank you.